Hello everybody, and today we are going to start a new lesson. It is factoring by quadratics, or solving by factoring rather, and we're going to be doing quadratics. So let's just take a look conceptually of what we're doing today. And so I have this graph and this quadratic expression, which is right here. Okay, and we're going to talk about what we've been doing and how that ties into kind of what we're going to do going forward. Okay, so what we've been doing is we've been factoring something that looks like this, okay, and where it's an expression, we've been factoring these expressions. In this unit, we are going to actually factor equations, and the only difference between an expression and an equation is the equal sign. So again, you factor them the same way. You do your A times your C up here, your B right there. No difference. A times C is 5, B is 6. Looking for factors of 6 that when added give me 5. Great. That just happens to be 5 and 1, right? So remember if A equal 1, then you're pretty much done here. You can put these two binomials as so. But now we are factoring equations, or we're actually solving by factoring these equations. So everything needs to be equal to 0, okay? And then from this up to this point, nothing has changed, okay? The only difference here is we are actually going to go one step further, and we're actually going to solve these, okay? And how you do that is you just put each one of these bits equal to 0. Okay, and you just solve it. It's just a one-step equation. You solve these like you have since 8th grade. Great. Now I have two solutions. Now these solutions are called a lot of different things. They're called solutions. They're called zeros. They're called roots. And what are these? Well, these are actually the place this quadratic crosses the x-axis. And these quadratics, if we were to look at the graph, and this graph right here, are these U-shaped kind of figures here. We call them parabolas. But they're these U-shaped parabolas that cross the x-axis. And we're looking for the place that these cross the x-axis. And if we look here, oh wait, x equals -5. Well, it looks like this one crosses at -5. It also crosses at -1. Okay, again, these are the solutions or the roots, the x-intercepts. This is the place that this parabola is crossing the x-axis. So let's get to the notes today. So that's just look at conceptually. That's not on your notes. But let's get to the notes so we can actually kind of fill in and go step by step here and look at some procedures of solving these quadratics by factoring. Okay, so these are just a couple warm-up problems. Nothing too crazy here. I mean, these are just one-step equations. Let's look at number 1 real quick. It says, hey, do you remember how to solve these things? And we kind of just went over that. X equals 3, yay. Okay, let's look at number 3. Number 3 is a little different. So now when we're solving these quadratics, what we're going to kind of do is we're going to take each bit and set it equal to 0. See how this has a kind of 2 bits here? We're going to set both of these equal to 0, and we are actually going to solve 2 equations. Well, now this one is just divide by 2. Okay, so x equals 0 here. And this one I'm going to add the 4 on both sides. So I'm going to get x equals 4. Okay, so nothing crazy there. That is, kind of what we're going to be doing today was we're going to take factoring a step further and actually solve these things. Okay, so let's answer the fill in the blanks below. The answer to these equations are known as solutions, okay? They are also called zeros, and they're also called the roots of the polynomial equation. Remember, since you are solving equations, you can always check your answer by substitution, meaning once I get, I'll explain it later, but once I get these numbers, I can actually go ahead and plug it into the equation, and it will actually turn out to be 0. So we'll do that on one of them. just to kind of show you what that means. Okay, I'm gonna skip the zero product property rule for right now. It's kind of intuitive, so I don't necessarily need to go over that. We'll just talk about how to kind of solve these things, and you'll kind of get the picture on that. So what solutions will work for x? So this is a two binomial, so it wants us to actually solve this for x. If I were to expand this out, I don't need to, but if I were to expand this out, it would be a quadratic that looks like x squared. And then I got, at the end, it's going to be 15. And in the middle, it looks like it's going to be, it's going to be 3 and -5. So it's going to be plus, no, it's going to be minus 2x. Okay, so this is actually what this quadratic looks like. Okay, if I were to expand it out, of course I'm not going to, because it's not going to really help me solve the problem here. But anyway, it wants us to go ahead and plug these in or solve these for x to find out what our zeros would be. Okay, basically you're going to subtract your 3 here, x equals -3, and then here it's going to be add the 5, so x minus 5 equals 0, plus my 5, x equals 5, okay? So those are actually my zeros there. If I were to plug any of these in, it would actually come out that my equation here would equal 0. Let's just try that real quick. I'm going to go rather quickly on this. You don't need to put this in. I'm just going to do this to kind of show you that it's a thing. And let's do it with 5. Because there's no negatives on that, it'll be a little quicker. So we got 5 squared minus 2 times 5 minus 15. Okay, kind of simplifying that out a little bit. I'm going to have, I'm just going to do a little arrow here. I'm going to have 25, because that's 5 squared, minus 10 minus 15. Well, what's 25 minus 10 minus 15? Well, that is 0 equals 0 here, guys. So just to show you, it is actually a thing. If you plug these in, you will get 0. All right, moving on. We're going to do a few of these. Again, on your first part of the assignment, remember you're doing odds. It's going to be similar to this. Hey, it's going to give me 2 expressions. We're going to do C here. You're just going to take each bit and set them equal to 0 and solve. So here we get x equals 0. And here we get plus 5, divide by 6, x equals 5/6. Great. Let's look at E, because E and F are actually kind of unique problems that you definitely will encounter later. So let's take a look at E. E here, you're going to set each bit equal to 0, but hey, you actually have a -1 out in front, okay? And then you're going to set, it doesn't matter which one you're going to put first. I'll just put the 4 first. And then we're going to have x minus 1 equals 0. And so now you're just going to solve these, like you would any one-step equation, right? So here we go. Does -1 equal 0? No, so I really don't care about that solution right there. It doesn't have any effect on my zeros, but then I am going to solve these. So here we go. I do have my zeros here, okay? And let's, just for fun real quick, we have a little bit of time. I'm gonna actually plug this into a graphing calculator and show you what this negative sign kind of does to these 2 binomials, which is a quadratic if I expanded it out. And here we go. We're gonna have negative parentheses x minus 4 close parentheses x, I forgot what the other one was, minus 1. So there you go. Now you have a parabola where it does cross the x-axis, so I do have 2 solutions like I kind of stated before, and it actually has 2. What you're going to notice different about this one is that negative actually flips this parabola upside down. So pretty interesting. We'll get to that at a later date some more. The fundamental theorem of algebra, that's kind of what we've been working on all the way up to this point. Basically, it says that, hey, any polynomial to the nth degree has nth many number of solutions or zeros. For example, hey, remember this is to the second degree here, right? Well, guess how many solutions it's going to have? 2. So I'm not going to do too much on that. We'll come back to that at a later date. But before I run out of time, let me just do a couple examples here, and I'm going to go through these rather quickly. So please pause and rewind, okay? So today we are solving by factoring. There's multiple different ways of factoring. We talked about GCF. We talked about the X method when A equal 1 and the X method when A does not equal 1. Okay, so we're going to go over those quickly just as a refresher on how to do these things here. So C is the first one we're going to look at. I will say this is a factor by GCF. Always look for a GCF. It could make your life a lot easier. So here I'm actually going to factor out a negative 10x, okay? And that's going to leave me, and when I factor out, it's kind of like division here. So I'm going to factor it out. What's going to be left over is an x here, and this is going to be a 3. Okay, now I'm going to solve each one of these and see what my zeros are. Well, I'm going to set this equal to 0. And I'm going to set this equal to 0. There you go. So here I'm going to divide by negative 10. I'm just going to get x equals 0. And for this one, I'm going to get x equals negative 3 because I'm going to subtract 3 on both sides. Let's take a look at number E. So E is actually when when A equals 1. So remember, some of you guys got pretty good at these. You're going to do it by the X method. No change here. Looking for factors of A times C that when added give me B. But something helpful is if you have a negative sign in front here, you need to go ahead and start your problem by factoring out a negative 1. Okay, and this is going to leave you with x squared minus x minus 42 equals 0. So now I'm looking for factors of A times C, which is negative 42, that when added are going to give me negative 1. Well, I'm going to tell you right now, I already kind of know what it is. It is actually negative 7 and 6. So here, my final factorization is going to be x minus 7, x plus 6, all equal to 0. So if I'm going to set each individually equal to 0 here, each individual bit equal to 0, I'm going to come up with something that looks like this. So I don't really care about this one. X equals 7 here, and x equals negative 6 here. Okay, and on to the last one you're going to do. Remember, H, always look for a GCF. In this case, it just happens to be x, okay? So I'm actually going to factor out an x before I even start this problem. So now I'm looking for factors of A times C that when added give me B. So AC up here, which is 98. And then my B is 47. It's actually negative 98. So I'm looking for factors of A times C that when added give me B. Well, it is actually 49 and negative 2. So I'm actually going to rewrite my problem with all this stuff in there. This is the part that a lot of you guys were not very good at. Everybody got pretty good at factoring when A equals 1, but when A did not equal 1, we all struggled here. So from here, I'm going to factor by grouping. Okay, I'm going to pull something out of each one of these. Here, I'm going to pull out a 7x. That's going to leave me with x plus 7 here. And on the other one, I'm going to pull out a negative 2 because I have to get these middles to match up. So I'm going to pull out a negative 2 out of this one. That's going to be with x plus 7. Right? Now I'm going to have 3 bits that I need to set equal to 0. That's one of them. My next one is this. And my next one here is this. So just to save you a little time is you just need to solve these for x, and that will be your final answer.